What is going on, guys, and welcome back to another one of the videos. Yeah, it has been quite a while since I've posted, but there's been quite a lot to do in my life, and yeah. Anyways, so back with the video. Actually, this is the follow-up to the video that I have done on the quadratic function introduction, where, if you guys can remember, we actually solved a triangle with sides x and x plus something. I can't remember exactly, but we used the quadratic formula, and the question is actually, why did we use it, and why is the formula like this, and what are quadratic functions? Why was there a square? What does that even mean? Alright, so maybe let's start off with saying what a function actually is. So functions are functions is something that puts two variables independent from each other. So you have, usually when you talk of functions, you have two different styles of writing this. You have f of x or you have y of x, right? So I usually prefer y of x, because if you plot this into a diagram, which means just drawing the function into a diagram, you're gonna see the y is on the y-axis. That's why we call it the y-axis, and the x-axis, and the x is on the x-axis. I don't like to use this because it is the function of x, is what it means, but the y represents already the y-axis. Alright, anyways, that's just as a side note. So yeah, so let's have a look. So I said that it puts two variables into dependence. What does that even mean? So you always have the dependent variable and the independent variable. So you have dependent and independent. You have the dependent variable and the independent variable, right? So if we have, well, let's just, I'm gonna stick with this, right? So if we have y of x, what does that mean? Well, we have a variable which, when we plug in a value, another value is gonna emerge from that. So in this, in the way that I've written it here, the independent variable is actually x, and the dependent variable is y. Now remember this, the way that I wrote it here, y of x, it's always the first letter is always the dependent variable, and the second letter is always the independent variable, or the letter that is written in the brackets. Which means, if I were to pronounce it this way, y is dependent of x, right? So yeah, what does this even mean? Well, if we have a basic function, like, let me use a different color here because I've written this all in red. So if we have y of x equals 5x plus 3, right? Let me just write that a little bit nicer for you. Equals 5x plus 3, then the variable, the x, is on this side, which means it's the independent variable. What does that even mean? Well, it means that if I plug in a value for x, let's just assume x is equal to 4, right? X is equal to 4. Then we can actually solve this equation, and we can see that if we were to plot this into a graph, which I'm going to be doing later, then you can actually see what y value will emerge from this. So we can actually just calculate this out. So we can write y of, and this is the way that you write it, when you have a specific function already given, and you have a specific value already given. So we just set x equal to 4, right? That's what we do. Now we just write y of 4. Why? Why? Because x is equal to 4. So instead of x, we write 4. That makes sense, I suppose. Good. And then we have y of 4, and we just continue plugging this in. So we have 5 times x, which is just 4, plus 3. And now you can already see that that is 23. So we have a point, P, with, when x is 4, I can actually write it like this. When x is 4, y has to be 23, right? This is basically what this means. Alright? Maybe let's actually draw a system here. So we have y there, we have x there. Now What is this plus 3? Let's actually clarify some of this plus, minus, what does this even mean? So 5x, this is the term, this is the part which says if there's an incline or a decline and how much or how big the incline or decline is. So actually there is this standard formula for linear functions, which is just y of x is kx plus d, right? And so you have k is the factor how steep, and if it's an incline or a decline in this example here. So if we just were to sketch this function right here, we could say 3 is here, right? 3 is right there, and then we can just say, okay, y of 4, which means we just have to find the value 4, which means if we, let's just say 4 is here, right? And we know that the y value of 4 is 23, so to sketch this function, I actually have already a point, right? And I'm going to go up, up, up. Let's just say 23 is like right here, right? So now how do we sketch this? Well, this is actually fairly simple. We just go up and to the right. Always parallel. Parallel to the coordinate system. Parallel to the y-axis, parallel to the x-axis. You go up and to the right, and here's another point. And also another thing to remember is when you have a linear function, you need exactly 2 points to sketch your function. Not more, not less. If you have 1 point, too little. If you have 3 points, it's still, you can still sketch the function, but it's more than you need. So let me just write this here. So we have linear, you need 2 points to sketch, right? 2 points to be able to do this. And what do we do now? Well, simple, we just connect these 2 points. There we go. And this is y of x equals 5x plus 3. This is what this is, alright? But basically, what does this even mean? Like, where do we need this? Just y of x, you know, no real world appliance. Like, I could do infinitely many of these functions, but what would this change? Well, why do we use these functions? Well, the good thing is that it puts 2 variables into contrast of each other. So what does that actually mean in the real world? Well, instead of using y and x, a example that I like to give is using, for example, money, right, and time, right? So this is basically another thing. So I could say, okay, I have $20 today, and every month I get 50 euros or $50, doesn't matter. And in let's say in 30 months, how much money am I gonna have? And of course, this is just a simple function, but or you guys could maybe calculate it even in your head, but this is actually what functions are, right? So if I say, let's actually take this example. So I have $30 today, right? What does this, or I forgot one thing. So we have the 5x is actually this is the incline or decline, right? Steepness, incline or decline, right? What does this d mean? Well, I think to understand this d, we have to actually look at what happens when we set x is equal to 0. So if we set x is equal to 0, we're on the y-axis, right? What does that mean? So this d is actually the point at which this function intersects the y-axis. Does that make sense? So look, again, I'm gonna say this again. You set x equal to 0, so this whole term goes away. This is just non-existent. So you have y of x is equal to d, or you have even better set. You can actually put y of 0 is equal to d, right? Because this is always the case. If x is 0, y is d, right? So d is just a point at which, in this case, again, 3, this is why I drew the 3 here, 3, 0, this point has the coordinates 3, 0, right? So if you have y is equal to 0, then always the height must be d. So this is the intersection with the y-axis. Great. Now let's get back to the example that I had before. So you have, let's just say it like this, right? You have no, let's not do it like this. You have m for money, and it is actually dependent on the time, because the more time that goes by, the more money you have, you know? So yeah, so let's actually, I said that I think in a month you get 50 euros, right? So you can actually do the same thing. So you just go like this, and you just go like this, right? You have t, and you get 50 times t. But please keep in mind that you have to put t in weeks, sorry, months. If of course if I say that it is in months, you have to plug this in months. And also, what is important to know is that, for example, when I'm 15 days into the month, about half a month into the month, then I'm not already gonna get my money, you know. So the always when it's days, months, it's kind of you have to kind of think where it makes sense. But this would be the function, or I could also just define that t must be. I'm gonna actually leave this to you guys. Think about this for a second. But no, t must be a whole integer, right? So how do I write this? Actually, I think t equals, and I think like this, right? Something like this. So you have t is part of the natural numbers, which is actually true, because you can't go into the negative time, and you can only have positive numbers and whole numbers, right? So this would be true if t were part of natural numbers. Anyways, so I think that by now we have established that functions put two variables into perspective or relative to each other. Alright. Now some people are gonna say, why do we have a dependent and an independent variable when it actually doesn't matter? And that is a great point. It does not matter, you know. Going back to that example maybe with the money, it doesn't actually matter whether you say in 3 months I'm gonna have this much money, or I'm gonna have this much money in 3 months, right? It doesn't really matter whether you plug in for the money or you plug in for the time. That's what's nice about these functions, right? So anyways, good. That is not actually the topic of today. I just wanted to have a little bit of an introduction for you guys. The topic of today is actually quadratic functions, right? So, what is a quadratic function? Well, let's first define it, right? So, quadratic function is this is the definition of a quadratic function. It is a polynomial function of the second grade, or you could grade 2 or of the second grade, it doesn't really matter. So, what does this actually mean? What is a polynomial function of grade 2? Let's have a look. So, I think I'll just draw a system of coordinates somewhere here. So let's have it here. Oh, yeah. So we have x. So, a polynomial function of grade 2 means that the biggest exponent, we're now talking about exponents, is 2, right? So, I'm sure that most of you guys have already seen this. Ax squared plus bx plus c, right? So this is the very, very basic way that you write this. So, and how is this a polynomial function of grade 2? Well, this squared, this x to the power of 2 is actually what this means. Polynomial function of grade 2 is 2. And for example, if I were to ask you what is a polynomial function of grade 3, then of course it's not that difficult. You just do the same thing, and ax3 plus bx2 plus cx plus d, right? This is a polynomial function of grade 3. Now keep in mind that the a is on the first place every time, or the a goes with the highest exponent, b goes with the second highest exponent, and so on and so forth. Good. So let's actually have this erased. So to actually sketch or to actually understand what this function even is, let's actually take the most basic thing that we can have, and which is this. This pen doesn't write. Y of x is x squared. Now this is the most basic way in which we can actually describe this function. And I'm going to ask you guys, what are the different values for a, b, and c in this function? Alright, let's actually have a look. So how would I actually think about this? So what times x squared equals x squared? Well, pretty simple actually. I mean, a equals 1, of course, right? And then you have, if somebody said 0, it's wrong, because 0 times x squared is 0. And we have x squared. Good, anyways. So we have plus bx. So there's no term here and no term there, which means that b must be 0 and c must be 0. And what does this mean? Let's plug in some values, right? So I'm going to actually make this red right here. Let's plug in some values. Let's say y of 0, right, is how much? 0 squared is just 0, right? Simple. Y of 1 is 1 to the 2 is 1. Easy. Y of 2 is 2 to the 2 is 4, right? And so on and so forth. So what you guys might actually know or don't know, but it's just going to be the square of of the following numbers. So 3 squared, 4 squared, and then 25, and then 36, and then so on and so forth. Good. So if we were to actually try to write this or sketch this in a system of coordinates right here, let's just say that this is 1. So I'm sure most of you guys know this, but we have a point at 1, 1, of course, on both sides. Oh yeah, I forgot to do this. If we plug in -1, what comes out? And remember, when squaring something negative, minus x squared is x squared, right? Because when you square this, what you're actually doing is doing this times -x, and which is just x squared, right? Because minus times minus is plus. So this is actually just plus x squared. So keep that in mind. So this is actually a symmetrical function on the y-axis. This specific function is symmetrical on the y-axis. Why? Because if we plug in y of -1, we get 1, right? And we do the same thing and we get the same values, which just means that it's actually symmetrical to the y-axis. Alright, so what is important to know, guys, is that this function right here, oh, yes, it's not very very nicely drawn, but anyways, this function here always increases more the more that you go to the right or to the left, right? So you can see that from 0 to 1 we have a change of 1, but from 0 to 2 we have a change of 4, and this is actually what this means, right? You guys know that the incline or decline k is equal to delta y over delta x. And again, if we have 1 to 1, that's just the point right here, we have k is equal to 1. Of course, that's the average. So the total. Let's not do it like this. That's just a little bit confusing. Anyways, what is important to know that this square actually means that it's the increase, the rate of change is actually getting more and more and more and higher and higher and higher, instead of linear functions, where it was the same all the time. All right. Good. So let's now discuss or have a look at what B and C actually are. So B and C are just variables, right? Which help us demonstrate or illustrate this parabola, is what we call this. It's actually a parabola, right? So I'm going to erase this and write y of x is x squared. Now, so A, what do you guys think will happen when I increase a? Let's say that a is 3. What does that mean? Well, we calculated before that the x squared, the a is multiplied by the x squared, right? So we have 3 times an x value. So actually, the parabola will look something like this, right? It will look something like this, right? Or something like this. So that actually means that we're changing the rate of change, right? We're changing the incline or decline of this function, right? So a up means incline, like, right? Does that make sense? Because we're multiplying the x value. We're not multiplying the y value, multiplying the x value by something. So in this case, we would have, if you remember, y of x is x squared. If we plugged in 1 for this function, it would be 3 times 1, so it would be 3. So instead of the 0.11, we would have the 0.13, which is just, I don't know, somewhere here. Good. Let's now continue. B. What happens when we make b bigger? Well, if we add another x, let's actually have a look at this, right? So we just say y of x is 2x squared plus 2x. Let's have a look at this, right? Let's maybe try to put this into this graph right here. So what we already know is that y of 0 is what? Y of 0 is 0, that's right. Because 0 times 2 is 0, this is 2 times 0, 0 squared is also 0, right? Good. Now we have y of 1. What is y of 1 in our instance? Y of 1 in our instance is 2 times 1 squared plus 2 times 1, which is just 4. Y of 2 is 2 times 2 squared plus 2 times 2, which is 2 times 2 squared is 8 plus 4 is 12. Okay, so it seems that we're also kind of changing the rate of change, but let's actually have a look at the negative values, right? So if we have y of minus 1, we have 2 times 1 minus 1, which minus 2, which is just equal to 0, right? We have y of negative 2, which is just equal to 2 times 4 minus 2, right? Which is just equal to 6. So actually we're noticing something different here. I must have made a mistake here. Wait a second. So guys, that was the graph of the function, which actually means, and it looks something like this, right? It was down here, down here, went through 1, and then I went through 0 again, right? Something like this. So what does that tell us actually? Well, in school you will learn that b is the amount that you basically shift this parabola to the left or to the right, and the value c is how far up or down it is. But you can see on this example that it doesn't really matter because the parabola is shifted down, although c is equal to 0. So I would not necessarily take it as a bet that you have b and c are equal to the coordinates of the lowest point or the highest point of the parabola, but you can approximate you can think approximately where it is. So what else can we do? So we just said we said plus 2, b is plus 2, but how is it possible that this parabola is on the left, right? Also, an important thing to know is that when the parabola is on the left, it's always plus here, right? When you have plus here, the parabola is going to be on the left. And when you have minus here, the parabola is going to be on the right. And when I'm talking about the parabola, I mean the highest or lowest point, which is, and in this instance right here, right? This is the lowest point of the parabola, which is on the left for a negative b value. And if we write, I don't know, if we put, and c, or let's just say it like this, that c is the value of which you actually shift this parabola up and down. And c is the same as the d which we've had before, right? So c is just the y value at which this parabola intersects the y-axis, right? So in this instance, as you can see, it has to go through the middle because c is 0, right? We can just put a plus 0 here, and we're not going to change anything, and we can see that it goes through, through the point 0, 0. All right, guys. So I think we've now established the basic understanding of these parabolas. One thing I would also like to mention, where's my pen? Oh, there it is. All right. One thing I would also like to mention is what happens when a is negative, right? So here you have negative a squared, right? Well, the parabola looks something like this. And how do we call this and this? It's open to the top and it's open towards the bottom, right? Because you can see the opening is towards the bottom and the opening is towards the top. So actually when I say a is positive, this is actually a rule. When I say a is positive, then I can say that it is open towards the top. And when I say that a is negative, I can say that a is open towards the bottom, right? Good. Right, so this is just any function. I could have actually chosen any function, but these are functions where the values are nice. You know what I mean? It's not like tricky values. Alright, so this is just any function, right? Now we can do the same thing as before. We can plug in y is equal to 0, y is 1, y is minus 1, and then we could sketch this, right? It's not what we're going to do. What we're going to do is, there is a special point here, right? There's a special point on the bottom here of every parabola, right? Or at the bottom, or on the top. And this is actually called, I don't know, I just can't think of the word in English. I looked it up now and it's actually a vertex, right? So I'll actually write both meanings here in German as in English. So we say S, right? And we put two brackets and we have XS and YS, right? These are the two coordinates where the vertex is, right? Good. Why is this important? It is important when you sketch this, when you want to sketch this, you know where to begin. It's also important to know where the highest and the lowest point of the function are. You know, when a is positive, you can say that the vertex is the lowest point of the function, right? Good. So let's actually have a look. Is there maybe a connection between this and some kind of form in which we can actually directly see what the vertex is? Well, yes, there is. And let's actually have a look at this. So to actually figure this out, the rules by which you do this is always isolate the x squared, right? So what you want to basically do is you want to complete the square, right? Use our binomial formulas. Use a plus b squared, right, in brackets. Use a minus c squared in brackets. Use, you know, whatever. Good. So let's actually have a look at this. So again, isolating the x. How do we do this? Well, we need to pull out the 2, right? We need to pull out the 2, which leaves us with x squared plus 4x plus 1.5, right? Now this by itself is definitely not a completing the square. It's not a perfect square, actually, what you call this. So we have to do some more math, right? So you have to do y of x is 2 times x squared plus 4x. And when you do this, you don't change this or this. What you change is the last expression, right? The last value. And you guys always have to think, what has to be the last value to complete the square, right? What does completing the square mean? We want to go from this form plus something else without an x to this form. We're going to go to this, right? A plus b squared. We want to go to this. We're going from this, wait, we're going from this a squared plus 2ab plus b squared. We go from this to this, right? How do we do this? How do we do this? Well, you have to think of a value which when multiplied by, which when taken to this, it's actually not that easy to actually explain, but you have a 1.5 here, right? And you have to think, this value is squared, and this value is just, and this value right here is just this value 2 times this value here that is going to be squared. And we know of one value that x squared is equal to 2x. And that is of course 2, right? X is equal to 2, right? So we know that x actually is 2, but it's squared, so we have to put also 4 here, right? So we have x squared plus 4x plus 4, because 4, if you take the square root of 4, it's 2, and you have 2 times x, which is 4x, so that's actually true. But we actually are changing the values. We cannot just do it like that without doing anything else. So what we have to do, if we added 2.5, we have to subtract 2.5 as well, right? Because we cannot just add a value and leave it like this. We're changing the function. That doesn't work like that. So now we have accomplished the preparation for the perfect square. And now what we can do is just factor this out. So what we're going to do, brackets, and now we have x plus 2, right? Minus 2.5 squared, right? So this expression, I can put brackets here, it doesn't matter. This expression, we went from this to this, and there we go, right? What do we do with this now? We can actually do this, 2 times x plus 2 squared minus 5, there we go, and that's it. Not that difficult. Let me actually check if that is correct. Where is it at? Yep, there it is. Alright, great. So, yeah. So you guys can see that this is not that difficult, but you just have to think, okay, going from this to this, what do I have to add? Where do I have to add the plus? Where do I have to add the minus? What do I have to do with this in general? Good. So again, so the way in which you solve this, always isolate the x squared, then think of a way to complete the square, and then just square it, and then multiply out the expression that is left over in the brackets. Now the question is, which of these, or what does this even do? Why did we do this? Why did we come here? Well, there's actually, from this, you can directly read what xs and ys is, right? So we have our point, which lies on xs and yx. And in this example, p, xs is 2, and yx is minus 5. And you can see how easy it becomes. We can just, from this form, right away say, okay, p must be a 2, 5, and that's it. So yeah, guys, one thing that I've looked up now is that the value which comes out here is actually negative. So we have minus 2 and minus 5. Great. Now, one more thing that I want to show you guys. What is this formula, guys? This is the last thing on today's list. What is this formula? Well, this formula shows us where y is equal to 0, at which points this function or any function intersects the x-axis. And now you might say, where the hell does this function intersect the x-axis? And that is a great point. It does not. So when actually calculating this, we always have to have something positive under the square root. I'm not going to make this too complicated. Let's just say that for what we have here, every solution that we have is positive under the square root, which also means that if it is positive, it has to have 2 points at which this function intersects the x-axis. Okay, and another question for you guys: what has to be under the bracket, under the square root for us to only have 1 point? Think of that. All right, I'll keep this question in mind and answer it later for you guys. Good. So let's have a look. So this is some random thing that we're taught to memorize, but let's actually maybe calculate it or do it in a way with which we can actually see how this, why this is and how this is. All right. So we said, what is true with this formula, right? With this formula, it's true that y is equal to 0, right? So we can actually pull out our base function, and we can just say 0 is equal to ax squared plus bx plus c, right? Because y of x is 0, so we plug in for y we plug in 0. We have just ax squared plus bx plus c. Good. And now we continue. So what do we want to do? We want to do the same thing as before. We want to complete the square. So we want to actually have x alone. So how do we do this? Let's have a look. So first thing I would do is divide by a. So actually the x squared is alone. And I'll also swap these two sides, right? So you have is equal to 0. You have x squared plus bx plus, sorry about that. I gotta divide by 8 plus b over a times x plus c over a is equal to 0. Good. Now the next thing I will do is get this out of here, because we have a c. There is no c here, and you guys can see already we're going to be completing the square with these two things, right? So let's just get this out of here. So let's just say minus c over a, right? So we have x squared plus b over ax is minus c over a, right? Good. And now the question is, how do we complete the square with this? And now this is actually, let's think here, right? So this is the middle term, right? This our b over ax is our 2ab, right? Now what we actually want is the a, because if we have 2ab, then we actually know that only ab must be half of this, right? So we have b over a x, but 2 here, right? And if we want to put the b away as the a away as well, which is the a is the, in this completing the square, you have a plus b squared. You have the a is the x, is not the x squared, but is the a. So you have here is the a, right? So to get this away also, right? So we have the 2 away. We just want to have the b isolated. So we also have to put this away, right? And now, what are we left over with? We're left with b over 2a, right? Good. But keep in mind, guys, our b from this expression is b over 2a, but this is b squared, so we have to square this whole thing. Do not forget that is equal to b squared over 4a squared. All right, let's not forget that. So what we actually want to do now is add this back in here. So we just write plus b squared over 4a squared. Great. Now we can do that. Add that in. B squared over 4a squared, and sorry about that. And also on the other side, of course. We'll do it in the next step. So we have x squared plus b over a x plus this is now what we are, or where we have gotten. And yeah, so now we actually complete the square. And let's just do that. That's fairly simple. We have already x plus b over 2a. And the same thing is equal to the other side. C minus a plus b squared all over 4a squared. Good. Now, this is of course squared, right? So let's actually write this down one more time. X plus b over 2a to the power of 2 minus, and what we can do here, what you can see, is we can actually first of all swap these two. So we have b squared over 4a squared, but we can also write minus 4ac over 4a squared, right? Because I just expanded with 4a on the top and on the bottom, right? Good. And now I can actually write is equal to, or this becomes 4a squared. This becomes b squared minus 4ac, right? And you can already kind of see where this is going, right? So let's just do this. So next step, square root, right? We have a square, we want to take the square, we want to have the x alone. Let's do that. So we now have x plus b over 2a is equal to this expression, but the square root of this expression, right? Square root of b squared minus 4ac over 4a squared. Now you might be thinking, where is this going? I have a 4a squared, and this actually looks kind of the same, right? This is actually already good. Well, the nice thing about math is that what we can do now is we can actually, from this expression, I'll maybe put it somewhere else so that I can actually stand. So I'll just copy this up here, right? X plus b over 2a is the square root of b squared minus 4ac over 4a squared. What can we do now? Well, I'll turn the camera a little bit more. There we go. We can actually take the square root on the top and on the bottom. That's what's nice about math, right? We have the properties of the square root, right? So we can just do this. X plus b over 2a is equal to, and because it's plus minus, we're taking the square root, right? Plus minus square root of b squared minus 4ac all over, what is the square root of 4a squared? 2a. And simple as that. Now we just go minus b over 2a, and we already have 2a, so we just get x, 1, 2 is equal to our formula. Minus b plus minus square root b squared minus 4ac all over 2a. And there you go. That's why this formula exists, because we said that we have a parabola which consists of the values a, b, and c, and of course the x values, and then we just said, oh wait a second, I gotta turn the camera back a little bit, there we go, and then we said, okay, we want the points at which this parabola intersects the x-axis, which is 0, which is when y is equal to 0, right? And then we just do some simple math, and we get to this expression right here. Alright guys, well, I want to thank you guys for watching today. Yeah, to summarize maybe, functions, you have an dependent and an independent variable, and functions are there to put two variables into relation with each other, right? So there's, you always have one variable which changes when the other variable also changes, right? That's what basically a function is. Good. Good. Then what we did, we drew some parabolas. We said, okay, we have one parabola here, which was y of x is 2x squared, and we said, okay, we want to know where the vertex is, and we calculated it out. And how did we do that? Well, we just put it in the form of the vertex form, or the Scheitelpunkt form, and yeah, that was very nice because we could just take the values right from there. We just said s and then brackets xs, ys, and yeah. And the last thing of today was that we, yeah, just proved or showed why this formula is the way that it is. Thank you guys for watching, and wish you a wonderful day, and see you in the next one.